I am Anil Kumar. Welcome to my series on vectors. We'll discuss equations of lines in this particular video. With the help of 7 examples, I hope you will get all the concepts required. Here is question number 1. State a direction vector of each line through the point 2, 3, minus 4 and 3, minus 5, 1. Y equals to 2x minus 3, x equals to 3, y minus 4 equals to over 2 equals to 1 minus z over 5. 4x minus 2y plus 10 equals to 0, and x plus 4, comma, y minus 4 over 2, comma, z equals to minus 3. You can always pause the video, answer the question, and then look into my suggestions. The very first one, we need the direction vector. So let's say the points given to us are A and B, right? So we want the direction vector for the line which goes from A to B. So the direction vector will be the difference of their corresponding values, right? So that direction vector will be equal to, we can write this as 3 minus 2 minus 5 minus 3 and 1 minus 4, which is minus 4, it becomes plus. So we can write this direction vector from A to B as 1 minus 8, 5, right? So that will be our answer. Now let's look into part B. We have y equals to 2x minus 3. Now this is given in slope-intercept form where we talk about change in x and change in y. But it is in the kind of reverse way when we talk about vector equations of a line, right? So this really means that delta y over delta x is equal to 2, right? Now when we are talking about the direction vector, then let's think about it like 2 over 1. Then we first write how when you move from one point to the other, how the x and y values change, right? So we'll write 1 and 2. So the direction vector is 1, 2 for B. C. X equals to 3, y minus 4 over 2 equals to 1 minus z over 5. Now whenever we are given in this symmetric form equation of a line, we have to write what this, we have to modify the last term. It should have been z minus something, right? So we could rearrange, and this really implies we could write this as x equals to 3, y minus 4 over 2 equals 2. We can write this as, we can write this negative for the direction. So it becomes z minus 1. You get the idea, right? Now you can give the direction vector. Now it's very important to see that we have x equals to 3 for all the points on this particular line, right? So the variation is not there along the x-axis. So in this case, the direction vector will be 0, and here it will be 2 and minus 5, right? So I hope you got the concept. So if you are given in the symmetric form, you should rearrange the equation as we did, right? So these are the direction vectors. Let's write down the direction vector of the next line. Now this is the Cartesian or the scalar form where the normal vector is 4 minus 2, right? So the direction will be, you flip and change one of the sign. So the direction vector here will be, you can write this as 2, 4, right? Now direction vectors should be written in this simplified form, right? So it is same as writing as 1, 2. Is it okay? So any one of these could be the right answer for you. Now we have similar to the part C, but I've left this for you to do. So that is your test question. Correct? So I'd like you to pause the video, answer the direction vector of this particular line, right? Here is the solution. once again, we'll kind of do the similar thing which we did. We don't have to rearrange, but think like this, x plus 4 over 1, right? So the direction vector here is 1, 2, and 0, right? So that is the direction vector. Now, question 1b for you, or I should say, is find a point on each of the above line. Is that clear? So find a point on each of the above lines. So that is an exercise for you. Let's move on to question number 2. Now I'll work with this symmetric equation of a line. Given the line x plus 3 over 2 equals y minus 1 over minus 5, find direction vector of the line. So clearly the direction vector is 2 minus 5, right? So the direction vector here is 2 minus 5. Find normal to the line. So the normal will be change 5 negative reciprocal, right? So the negative and then reciprocal, so flip it. State a point on the line. So the point of the line will be minus 3 and 1, right? So point P could be minus 3 and 1. State vector equation of the line. Now once you know the point and the direction vector, we can write the vector equation of the line as begin with the point which is minus 3, 1, right, plus t times the direction vector which is 2 minus 5, where t belongs to set of real numbers, right? So that becomes the vector equation of your line. State Cartesian equation of the line. Now for Cartesian equation, the best method to do is something like this. We'll rewrite this symmetric equation, which is x plus 3 over 2 equals to y minus 1 over minus 5. We'll cross multiply, right? So we get minus 5 times x plus 3 equals to 2 times y minus 1, right? Now we can bring all the terms to one side, keeping the coefficient of x as positive. So let's first open the brackets. We get minus 5x minus 15 equals to 2y minus 2. Bringing it to the right side gives us 5x. We have plus 2y there. Minus 2 plus 15 equals to 0, or 5x plus 2y plus 13 equals to 0. So this becomes the Cartesian equation of the line, right? So 5, 2 is your normal. Do you see that? 5, 2 is your normal. So I hope that helps. You could have done it directly also, because we did find the normal 5 and 2. So you could have written, so alternate method could be, you could write this as 5x plus 2y plus some constant k equals to 0, and then use the point to find the constant, right? Find k using the given point. So I'd like you to adopt method 2, alternate method. That will be your question 2 extended. Is that okay? Fine. So let's move on and look into question number 3. Question number 3. Find parametric equation of a line that passes through point A, 7, 2, and is parallel to the line 4x plus 3y minus 1 equals to 0, right? So we are saying parallel to line which is 4x plus 3y minus 1 equals to 0, right? So that means we could write this as 4x plus 3y plus k equals to 0, right? So that is a line which is parallel. Perfect. So k value is going to be different. And now we are given it is pass through the point A, which is 7, 2. That really means we can substitute 7 and 2, which lies on this particular line, find the value of k. So putting 7 for x, we get this, right? 3 times 2 plus k equals to 0, which is 28 plus 6 plus k equals to 0, which is 34 plus k equals to 0, and that means k is equals to minus 34, and therefore the equation is 4x plus 3y minus 34 equals to 0, right? So that is our answer. So this is a method to solve this question, and I hope you will understand that this method could have been followed in question number 2 also, right? Question number 4. Show that the points A and B lie on a line that passes through this point and has the direction vector of that. Okay, so what we can do here is we can have different ways. So let me write the parametric equations. We have, let me write down first what we are given. We are given a point which is 0, 0, 3. We are given a direction vector which is minus 3, 1, minus 6. So we can write a parametric equation, right? So the x value will be equals to 0 plus minus 3t, right? So which is minus 3t, or we can write this as minus 3t. Y value will be 0 plus 1t, right? 0 plus t, which is just t. And the z values will be 3 plus minus 6t, right? Which I'll write as 3 minus 6t. Correct? So that could be your parametric equations. Now we need to show that A and B lie on this particular point, right? So the value of A is 6 minus 2 minus plus 15. So let's substitute these values, find the value of t, right? So if I write the value of A, now A is 6 minus 2 and 15. So if I write 6 here, so we get x equals to minus 3t. Using 6, we get 6 equals to minus 3t, and that gives t as 6 over minus 3, and that is the value of minus 2. Right? So now, we found the value of t by substituting 6. Now we'll substitute t as minus 2 and check do we get the other results. Okay, so from here, we can say y equals to t, which is minus 2, and z equals to 3 minus 6 times minus 2. So let's calculate. 3 times minus and minus becomes plus 12, which is 15. So we do get a point which has these values. Clear? So that confirms that yes, A is on the line, right? So 6 minus 2 and 15, it is point on the line. Confirmed. So similarly, you could substitute the other values and find the point on the line, right? So what you also note is that we have x equals to minus 3t and we want x equals to minus 15. Clearly, t is equal to 5. You could work like this. So if t is 5, then y is equals to 5 and z is equal to 3 minus 6 times 5, which is 3 minus 30, or is equals to minus 27. And that gives you the point which is minus 15, 5, and minus 27, right? So that is how you could check that the point lies on the given line. Perfect. Let's move on and take the next question. Question number 5. The lines kx plus 4y minus 4 equals to 0 and 3x minus 2y minus 3 equals to 0 are perpendicular. Find the possible values of k. So if they are perpendicular, that means dot product of their directions vectors is 0, right? So, or you can say direction vectors, or even you can say dot vectors or direction vectors or normal vectors. Both, right? So direction vectors or normal vectors. So in this case, when you're given in the Cartesian form, let's use the normal vectors, right? So n1 for us is k4, right? And n2 is 3 minus 2, right? So n1 dot n2 should be equal to 0. Now what is n1? Which is k4 and this is 3 minus 2, right? So we get 0 equals to 3k minus 8. And from here we can find the value of k is 8 over 3, correct? So we get our answer, and the answer is k equals to 8 over 3, right? So that is how we could find this answer. Question number 6. Show that the following lines are parallel and non-coincident. So parallel means what? Parallel means direction vectors, or you can say normal vectors, are scalar multiples, right? So then they become parallel. And now second thing is have no point in have no common points, right? That is kind of important. So we can check with their direction vectors. So we know this is 3 and minus 4. So if I multiply this by 2, I do get 6 and minus 8, right? So we see that's a scalar multiple, right? So that means they are parallel. Correct? Now how to show that they are not coincident? So if the value of x is 0, so we can just substitute one value of x and find the value of y, correct? So that could help us to figure out whether they have the same points or not. So if we say if x equals to 0 in line 1, right? In line 1, if x equals to 0, then what is the value of y? So the value of y, we have 4y equals to 6, or we get y equals to 6 over 4, which is 3 over 2, right? So that is what we get. Now if I do the same thing on the second line, so in line 2, if x equals to 0, in that case we have 8y equals to 12, y equals to 12 over 8. Now dividing by 4, we get 3 over 2. In the first case, this was negative, sorry. This one is positive. So what you see here is that the y value is 3 over 2. So we have a value here 0 minus 3 over 2. On the other hand, we have 0 plus 3 over 2. This is one way of doing it, right? The better way is, if I times the whole equation by 2, what do I get? So if I do that, from here, I get 6x minus 8y minus 12 equals to 0. Now since we have these two different, right, minus 12 and plus 12, they are different lines. So the lines are not coincident. Is that clear to you, right? So I think this is a better method. Just do scalar multiple of your line and then say that the constant value is not the same, right? So that is how you could figure out that the lines have different y-intercept or whatever you may say, or different x-intercepts, and so they are not the same. So that brings us to the last question, which is question number 7 for us. Now let us see how to solve this question. For the line r equals to 1 minus 5 plus s times 3 5, where s belongs to real, determine parametric equation of the line perpendicular to L passing through a given point. Now for part A, we are given the direction vector which is equal to 3 5, right? So the normal vector will be 5 minus 3. Now we need parametric equation passing through point which is 2 0. So the x value will be now 2 plus, let us say, 5t, and the y value will be 0, 0 minus 3t, right? So that becomes the parametric equation. Perfect. So the parametric equation is this, which, let me write down here. Our answer here is that the parametric equation is x equals to 2 plus 5t and y equals to minus 3t. Now part B is the point at which the line in part A intersects y-axis. So when we do y-axis, that means x value, y-intercept, right? That means x equals to 0. So if I write x equals to 0, I get 0 equals to 2 plus 5t. The value of 5 will be minus 2 over 5. Correct? That's the value of t. Now substituting t here, we get the y-intercept y equals to minus 3 times negative 2 over 5. That is 5 times 3 times 2 is 6 over 5. So the y-intercept is 6 over 5. So therefore, y-intercept is at 0, we get 6 over 5. Is that clear to you, right? So that is how we are going to answer this question. So that brings us to the end of this introduction to equations of lines. With the help of these 7 equations or the questions, we have really understood different forms of the lines and how to read from them direction vectors, normals, and how to figure out whether the point lies on them or doesn't. Now in the next video, we'll take up a test to understand the equation of lines better. Thanks for your time, and I hope and wish you liked all these videos. If you like and subscribe to my set of videos, that'd be great. Thanks for watching and all the best.